This lecture video is about section 4.11, and it's an introduction to nonlinear problem solving. So in this section we're going to be looking at the square root function, and this first problem here, the time t is the output in seconds that a basketball player spends in the air during a jump, and it's called the hang time, and depends on the height s, which is going to be our input, and it's going to be in feet. Of the jump according to the formula t equals 1/2 times the square root of s. To determine the hang time of a jump 1 foot above the court floor, you perform a sequence of two operations. You start with s, which is 1 foot, and you have to take the square root of it and then multiply it by 1/2. And the square root of 1 is 1. After you multiply by a half, then you'll end up with 1/2. A function such as f of s equals 1/2 times the square root of s is known as the square root function because determining the output involves taking the square root of an expression involving the input. A good college athlete can usually jump about 2 feet above the court floor. Determine his hang time. And so again, the hang time in this is t, that's how long they would spend in the air, and s is the height above the ground. So this 2 feet is s, and we want to calculate t. And so here's the function in function notation, and so we want to find f of 2. So that will be 1/2, and then times the square root of 2. So we're just going to replace this s with 2. And so that's going to be 1/2 times, and then just take your calculators out and find the square root of 2. And so in my calculator I do have a square root key, and on my calculator I have to push the square root key first and then type in the 2. Yours might be a little bit different. So I actually have a button that has, and it's actually one of the buttons I have to push the second key for, and it's really second, and then I push the x squared button. And right above the x squared button is a green square root symbol. So you'll have to figure out where yours is on your calculator, or you may just type in this caret symbol and then type in 1/2 would be the same as a square root. Okay, so this would be the same as a square root, or like I said on my calculator, I have a second. Second means that I'm going to use whatever's on above the key, and above my x squared key is a square root symbol. So I would push second and x squared, and then I type in my 2, and when I hit enter, my calculator actually gave me square root of 2 as my answer. So in order to fix that so that you get a decimal, just put a decimal point at the end of the 2, and that will force your calculator to give you a decimal answer. And so I'm just going to try this again. And then I'm going to do 2 decimal point, and when I hit enter this time, I get 1.4142, and I'm just going to go out to 3 decimal places. And then I want to multiply that by 1/2, and so I'm going to take my answer and multiply it by 0.5, and so that gives me 0.707 if I stick with 3 decimal places. And we should always put units on this, and this would be seconds. Okay, so if you jump 2 feet in the air, then you would spend 0.707 seconds in the air. Michael Jordan is known to have jumped as high as 39 inches above the court floor. What was the hang time on that jump? So now I want to calculate f of, and this is in inches, and notice that up in our equation, time t, or the output, so that's in seconds, but this s is the distance, but it's in feet. And so we need to convert this into feet. And there are 12 inches in a foot. And so take 39 and divide it by 12, and that will give you the number of feet. So when we take 39 and divide by 12, we get 3.25. Whoops. Okay, so that's the same as 3 1/4 inches. So we're going to plug 3.25 into our function, and so that's going to be 1/2 times the square root of 3.25. And so we'll have 1/2 times the square root of 3.25 gives us 1.803 if I round to 3 decimal places, because it was 1.802, and then followed by a 7. So we would have to round that 2 up to a 3. And now I'm going to take 1.803 and multiply that by 1/2, or 0.5, that's the same thing, and I get 0.9015, and so I'm going to round the 1 up to a 2 because I'm just rounding to 3 decimal places. And this was seconds, so almost a second in the air. Using the hang time formula for the data regarding Michael Jordan's hang time on a 39-inch jump Use the hang time formula and the data regarding Michael Jordan's hang time on a 39-inch jump to determine whether it's reasonable for a professional basketball player to have a hang time of 3 seconds, and explain your answer. So Michael Jordan, his jump was 39 inches, and it was not even quite a full second yet. And so is it reasonable to think that someone could have a hang time of 3 seconds? And I would say no, that's not reasonable. So what would happen? So this would mean that the left-hand side of our equation would be 3, and that would have to be equal to 1/2 times the square root of s, which is the distance that we jumped in feet. And so we can figure out how many feet this would be. And so for right now, I'm just going to say no, and it's because this is too much larger than Michael Jordan's. And I just want to see if... So we're not going to solve this. So let's just solve this and see just how high we would have to jump in order to have a hang time of 3 seconds. So in order to undo this multiplication by 1/2, we would have to divide by 1/2. Or divide, that's the same as dividing by 0.5. And if you divide 3 by 0.5, you'll get 6. So 6 is equal to the square root of, s. And then to undo a square root, you would have to square both sides. So we would want to square both sides of this. And 6 squared is 36. And then this square root and the squaring cancel each other out, and we would just be left with s. And remember, s is in feet, so in order to have a hang time of 3 seconds, you would have to jump 3 feet. Sorry, not 3 feet, 36 feet. So in order, like I said, in order for us to have a hang time of 3 seconds, we would have to jump 36 feet, and there's no way that a human could jump 36 feet. So that would be impossible. Now we want to answer each of the following questions. What would be a reasonable domain and range for the hang time function having the equation t equals 1/2 s squared? So what numbers would be reasonable for us to plug in for s? So this would be our domain. And so what's a reasonable distance for somebody to jump? I don't know, Michael Jordan could jump 3 1/4, so let's say that the highest anybody could possibly jump would be 4 feet. So I would say from 0 on up to 4 would be a reasonable domain. And then the range would be the t values, and I guess I'm not going to put an equal sign there. I'll do a couple dots. So for the range, what would be a reasonable range? Well, Michael Jordan only had a hang time of almost 1 second, so I would say from 0, and we'll extend that out all the way up to a full second. I think anything beyond that would probably not be very reasonable here. Now I want to complete this table, and so this is feet in the air that we jumped, and we want to calculate the hang time. And so our formula, remember, is f of s equals 1/2 times the square root of s, where this s is our distance. So if we plug 0 in here, the square root of 0 is 0, and then 1/2 times 0 is going to be 0. So of course, if you don't jump, you won't have any hang time. And if we plug 1 in there, the square root of 1 is 1, and 1/2 times 1 gives us 1/2. And we already did 2. And I'll just recalculate it instead of scrolling back up. So I want to do the square root of 2, and remember to put a decimal in there if your calculator just gives you the square root without it. And so that was 1.4142, and so I want to do 1.414, and then multiply that by 1/2. And that gives me 0.707. And then do the same thing for 3. So we're going to take the square root of 3. That gives me 1.732. And multiply that by 0.5. And I get 0.866. And for 4, the square root of 4 is actually 2, and 1/2 times 2 gives us 1. So somebody would have to jump 4 feet in order for us to have a hang time of a second. Now we want to plot the points. So t is going to be our x variable. So this is t, and remember this was our hang time. No, this was not our hang time. This was the height of our jump. No, sorry, this was our hang time in seconds. So now let's plot these points. So t again is our hang time, and that's going to be on our x-axis, and then s is our distance in feet. And this is in seconds. And so we have the point 0, 0. And we have the point, and we're doing this backwards. I'm going to stop my video. Okay, I double-checked the textbook, and this is the way that they have it written, but they really want us to plot s on the x-axis and t on the y-axis, which is kind of what I figured and was a little bit hesitant about. So let's go ahead and make that change. And so this should really be s, our distance in feet, and this is our hang time. And that was in seconds. All right, so that's better. And so then we have the point 1, 1/2, and we need to mark our axes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 11, and we need to go from 0 to 4. So I'm just going to do this as every other. So that would be 1, and here's 2, and 3, and 4. And then we only need to go from 0 up to 1 on our y-axis, and we have 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to do each of these as a quarter. So 1, 2, 3, 4 would be 1. And that's actually as high up as we will need to go on this. Okay, so we have 1 1/2. So this would be our point 1 1/2. And then we have the point 2 and then 0.7. And so this is 0.75 right here, so it's going to be a little bit under that. And then we have the point 3 and almost 0.9. And so this is 0.75, and that's 25 units in there, or 0.25 units in there. So we'll say that's about right there. And again, you don't have to be precise on this since they're decimals, and that was 0.866. And then we had the 0.41, which is right here. Sorry, that's a little bit covered up. And then we would connect these dots and extend it out a little bit and put an arrow on there. And so there's a picture of our graph. And all square root functions have a similar shape to this. And basically, if we were to draw this down here, a mirror image, it would give us a parabola on its side. And so that's basically what this is half of a parabola. And we've looked at those graphs already. So now I want to answer each of the following about the hang time function. Is it a linear function? And the answer is no. And the reason that it's not, and we want to use the graph to explain that, and so these points don't lie on a line. We'll say land on a straight line. Okay, the next one, solve the hang time formula in terms of s. So we want to solve this equation for s. We have t equals 1/2 times the square root of s. So we're trying to get this s alone. So the first thing that I need to do is undo this multiplication, which means I'm going to divide by 1/2. And remember, when you divide by a fraction, that's same as multiplying by its reciprocal, and the reciprocal of 1/2 is 2. So this would give us 2t equals the square root of s. And then remember, to undo a square root, we would square both sides. And 2t times 2t gives us 4t squared. And then this squaring undoes the square root, so we'll just be left with s then. So s is equal to 4t squared. Use the formula you obtained in part B to explain why the relationship between s and t is not linear. So if this had been linear, then this resulting equation would have been linear. And we can tell by looking at this equation for s that it's not linear because we have a t squared in there. So linear would mean that you could only have a t and not any other powers of t. In this next grouping of problems, we want to solve for each of the variables. And so the first one is square root of x equals 9. And so this is basically saying, what number can we take the square root of so that we get 9? Well, so you might be able to just figure that out reasonably. You know, it would be the square root of 81 is 9. Or the way that we do it algebraically is we square both sides of this. And again, squaring a square root, basically they cancel each other out, and so that leaves you with just x, and 9 squared is 81. In example B, we have the square root of t plus 3 equals 10, and so now we want to get this squared alone first, and then we want to square both sides. So first we're going to subtract the 3 from both sides, because I need to get this square root of t by itself. So I'd end up with the square root of t is equal to 7, and then at this point, now that we have this squared alone, we can square both sides. And then the square root and the square cancel each other out, leaving you with just t. And 7 squared is 49. And you can plug this number back in to check and make sure that your solution works. Square root of 49 is 7, and then when you add 3 to it, you do in fact get 10. Okay. In example D, we have the square root of t plus 1 equals 5. So now we do have this square root by itself already, so we can just go ahead and square both sides right away, because this 1 is underneath the square root. This 3 was not. That's why we had to subtract the 3 first. But since this plus 1 is underneath the square root, we're going to square both sides right away. And then the square root and the square cancel each other out, leaving us with just t plus 1. And 5 squared is 25, and then we would subtract 1 from both sides. And that gives us t is equal to 24. And again, you can check your solution. 24 plus 1 is 25, and the square root of 25 is 5. And so the solution does work. Our next example here, we have the square root of 5t equals 10. Again, this square root is by itself already, and since it's alone, you can go ahead and square both sides right away. And then the square root and square cancel each other out, leaving you with 5t, and 10 squared is 100. And then to get t alone, we would have to divide by 5. That gives us t is equal to 20. And again, you can plug that 20 in. 5 times 20 is 100, and the square root of 100 is 10. And so our solution did work. And looky there, I accidentally skipped one, and I called example B, or not example B, but what was that? Example D, example C. So sorry about that error. Example C, we have 4 times the square root of x equals 12. Again, we need the square root alone, and this square root is not alone right now. It's being multiplied by a 4, so we need to undo that multiplication of 4 first. So divide by 4 on both sides. These 4's cancel, leaving you with the square root of x. And 12 divided by 4 is 3. And then we want to square both sides. And the square root and the square cancel each other out, leaving you with x. And 3 squared is 9. And again, you could check this back up in the original. Square root of 9 is 3, and then multiply by 4, you do get the 12 that we were looking for. In example F, we have the square root of 2t minus 3 equals 0. So again, we have this minus 3 outside of the square root over here, so we need to undo that. Oops, I don't know what I just did. Something though. And so we need to undo that, so we're going to add 3 to both sides. And that'll give us the square root of 2t equals 3. And then we want to undo this square root now, so that means square both sides. The square root and the square undo each other, leaving you with 2t. And 3 squared is 9, and then we need to divide by 2 to get t by itself. And so we get t is equal to 4.5. And the last couple of problems are to do some graphs. And remember, the square root graph always sort of has this shape. It looks like a parabola. So remember, if we draw on a dashed line, it's like a parabola on its side, only it's missing half of it. Okay, so that's what shape we're going to have, and we can just go ahead and plot points. And you have to be a little bit careful when you're picking your points to plot, because we're taking the square root of whatever number we're plugging in here, and you can't take the square root of negative numbers. So we couldn't put -1 in for x, and we can't put any negative numbers in, so the smallest thing we can put in here is 0. And the square root of 0 is just 0. And then pick your x's so that they give you nice numbers. You can put whatever you want in there, but I always try to pick perfect squares or numbers that will give me perfect squares when I plug it into x, so that we're taking the square root and we get a nice result back. It just makes graphing a lot easier. So we can take the square root of 1, so we'll do 1. The square root of 1 is 1. You can't take the square root of 2, though, so I would skip over 2. And you can't take the square root of 3, so I would skip 3. But we can take the square root of 4. It's 2. So I would use 4. And then you can't take the square root of 5 or 6 or 7 or 8. The next one would be 9, and the square root of 9 is 3. So I would say, for me, if you have 3 points plotted, that's enough. Okay, so, and I'm just going to do, each tick mark is 1, so I have a point 0, 0, and make sure that you label everything all the points you put on your graph. 0, 0, and then we have 1, 1, and then we have the point 4, 2. And then you can draw in your graph. So our next one here, we have f of x equals 3 times the square root of x. And so again, we could plot some points. And so it would be the same points that we put in before for x. 0, 1, 4, and I wouldn't even bother with 9 because now we're multiplying the square root by 3, which means it's going to be even bigger than the numbers we had before. So I would just go with those 3. So square root of 0 is 0, and when you multiply 0 by 3, you get 0. Square root of 1 is 1, and then multiply that by 3, you get 3. Square root of 4 is 2, and 2 times 3 is 6. Okay, so we have the point 0, 0 again. And then we have the point 1, 3. And then we have the point 4, 6. And these always look the same, and so this is going to be going up like this. Remember, this is like half of a parabola. In our next example, we have f of x equals the square root of x plus 3. So we're going to plot some points. And once you see what happens when you have a number underneath the square root, you could use that pattern to your advantage. And so, so we'll plot some points, and we have f of x equals the square root of x plus 3. So now, the number that would make this underneath our square root be 0. And you could just solve this equation. So the numbers that we want to put in here, we want to do the square root of 0, 1, and 4, like we did before. So we want the thing underneath the square root to be 0. And so if x plus 3 is 0, then x would have to be negative 3, because you would subtract 3 from both sides. Then if we wanted to take the square root of 1, then that would mean that x plus 3 would have to be equal to 1. And if you subtract 3 from both sides of this, you get x equals negative 2. And the next number that we want our square root to be, or that we want to take the square root of, is 4. And so we want x plus 3 to be equal to 4. And so we would subtract 3 on both sides here, and that would give us x equals 1. Okay. Okay, and 3 points I think is enough. If you need to go up one more, then we would want x plus 3 to be equal to 9. And subtracting 3 there would give us x equals 6. But again, like I said, I think 3 points is plenty. So if I plug negative 3 in here, I get the square root of negative 3 plus 3, which is the square root of 0, and that's 0. Then plug negative 2 in there, we would get the square root of negative 2 plus 3, and negative 2 plus 3 is 1, and so we would get square root of 1, which is 1. and then plug 1 in there, we get the square root of 1 plus 3, which is 4, and the square root of 4 is 2. So I have negative 3, 0, and then I have negative 2, 1, and then we have 1, 2. And then you can go ahead and draw in your curve. Okay, so notice what happened. Because I had a plus 3 underneath my square root, it shifted my graph to the left 3 units. So if you have plus 3, it shifts your graph to the left 3 units. If this had been a minus 3, it would have shifted it to the right 3 units. Okay. So now I have f of x equals the square root of x and then plus 3, but the plus 3 is outside of the square root. So now picking my points is easy. It's going to be the same points that I was using up above in the first couple of examples. And so the x values that I'm going to plug into this square root are 0, 1, and 4. And the square root of 0 is 0. And then I add 3 to that, so I get 3. Square root of 1 is 1, and then when you add 3, you get 4. Square root of 4 plus 3, that's 2 plus 3, or 5. So now I have the points 0, 3, and then I have the point 1, 4, and then I have the point 4, 5. And then again, you can go ahead and draw on your curve from there. And so notice from the original graph that I had, it's just been shifted up 3 units. Okay, so a plus 3 outside of the square root is going to shift it up 3 units. If it's underneath the square root, it shifts it to the left 3 units. Now in this next example, we have a minus 3 underneath the square root. And so if we had a plus 3 underneath the square root, it shifted it to the left 3 units. So this is going to do the opposite of that. It's going to shift it to the right 3 units. And so let's just take a look at that. And so we want what's underneath the square root, to be the same as what we had before. So we want x minus 3 to be equal to 0. If you add 3 to both sides of this, that means I want x to be 3. And then I want x minus 3 to be equal to 1. And so if I add 3 to both sides of this, I get x equals 4. And then I want x minus 3 to be equal to 4. And then when I add 3 here, I get x equals 7. So 3, 4, and 7 are going to be our points. Square root of 3 minus 3 is the square root of 0, or 0. Square root of 4 minus 3 is the square root of 1, which is 1. And the square root of 7 minus 3 is square root of 4, which is 2. So I have the point 3, 0. And I have the point 4, 1. And I have the point 7, 2. And then you can draw your graph in, and you can see this shifted our graph 3 units to the right. Now in this last example, we have a minus 3, but this time it's outside of the square root. When we had a plus 3 outside of the square root, it shifted our graph up 3 units. So this one is going to shift it down 3 units. And again, picking the x values this time is easy because the only thing under my square root is x. So they're going to be 0, 1, and 4. So square root of 0 minus 3 is negative 3 because it's 0 minus 3. And then square root of 1 minus 3 is 1 minus 3, or negative 2. And square root of 4 minus 3 is 2 minus 3, which is negative 1. So I have 0, negative 3, and I have 1, negative 2, and I have 4, negative 1. And so there is a sketch of that graph. Okay, that's it for this lecture. If you have any questions, let me know. Thanks.